I tell my students every single year when we start equations, we focus on one step right off the bat. The only problem is if you don't master one-step equations, well, then the next lesson's two-step equations. Then it moves on to multi-step equations. Then we're talking about variables when they're on both sides of the equal sign. Well, if you don't master the one-step equations, how do you think the rest of them are going to go? It's time to lock in. Let's get into one-step equations. Can I be honest for a minute? I don't really know why I made that introduction so aggressive, but I'm not going to change it. So hopefully you're feeling a little frightened right now. Maybe you are locked in right now for one-step equations, as you should be, of course, because who wouldn't want to be locked in for one-step equations? So let's go ahead, jump into number one. I'm going to show you exactly what I taught my students for one-step equations so you can do the same in your classroom. Or maybe you're a parent, you're like 60 years old and you're trying to help your kid out. This video is for you. So for number one, I always tell my students to build a wall. I want you to separate the left side and the right side of the equal sign. So let's go ahead and do that first. So I'm going to draw a line right through the equal sign, which is essentially building a wall. We want to separate the left side and the right side. And our goal with this is to get the variable isolated or by itself. Doesn't matter if it's on the left side of the wall or the right side of the wall. Now in this case, it's on the right side. We're trying to get the variable m by itself. But there's a -3 on the same side of the wall as it, and we want to get rid of that. And the only way to get rid of those numbers is utilizing inverse operations or opposite operations. So you first have to know, well, what operation's going on to begin with, and what's going on between -3 and m. I don't see addition, I don't see subtraction, I don't see multiplying, and I don't see division. And whenever we have a number right up against a variable like this, it's always multiplying. So the only way to get rid of multiplying is let's do the inverse and divide both sides on both sides of the wall by -3. So we want to make sure that we showcase that by dividing by -3 on both sides. -15 divided by -3 is going to give us a +5. We'll bring down our equal sign, and then -3 divided by -3 is 1. Well, what is 1 times anything? It's just going to stay the exact same. So we can cancel those, and we'll be left with just the variable m isolated by itself on the right side. Now, some people don't like writing the variable on the right side just because it doesn't look natural to them. So once you get down to the very end where you have the variable isolated, feel free to just kind of flip-flop it. So instead of it being 5 equals m, feel free to just do m equals 5, and you're going to have the correct final answer regardless. So now let's go ahead and take a look at number 2. Again, let's build that wall, separating the left and the right side. And this time around, we want to isolate the variable w. And I do see an operation this time. It's a -9. Well, how do you get rid of subtracting by 9? We're going to do the inverse and add by 9 on both sides. So let's go ahead and show a +9 here, as well as on the other side of the wall. Subtracting by 9 and adding 9 are opposites. Those are going to cancel. And we're left with the variable isolated by itself on the left side, which is w. We have our equal sign. -23 plus 9 is -14. And our final answer for number 2 is w equals -14. And now on to number 3. Let's go ahead and build that wall once again. And how do I get the variable s by itself or isolated? I do see a 17. Well, how do I get rid of that 17? We are going to subtract 17 on both sides. So 17 minus 17, those are going to cancel, and we're left with 0 there. Well, don't write 0 plus s because 0 plus anything is going to be the exact same. So we have s isolated just like we want, equals, and then 5 minus 17 is going to give us -12 for number 3. And then finally, the very last one in this row before we jump down to the bottom two, we have x over -2 is equal to 7. And you're going to notice that the variable is a part of the fraction here. And remember that fractions are just division. So this is x divided by -2. Well, what's the inverse of dividing by -2? We're going to multiply both sides by -2. So let's go ahead and build that wall first. We're going to multiply by -2. I'm probably going to run into the problem number here. So I'm going to write it up a little bit. So multiply by -2. Multiplied by -2. Now, I want to show you why this works. So let me actually erase this a little bit so it makes more sense. When you're multiplying by -2 here, that's essentially -2 over 1. I know it's a little bit cramped. Get over it. Okay? Look at the numbers that are diagonal from each other. -2 and -2. Well, Negative 2 and negative 2 are both divisible by negative 2. Well, what's negative 2 divided by negative 2? It's just 1, right? So this is going to cancel. This would become 1. This would cancel. This becomes 1. And our denominator is already 1 in the other fraction anyways. So all of this is just 1 times x, which leaves x isolated all by itself on the left side. So x equals, and 7 times negative 2 is negative 14 for number 4. And that's essentially why that works. You know, the inverse of division is multiplying. Well, if you put it over 1, look at the numbers that are diagonal from each other. They're divisible, okay? And you can simplify it all the way down to 1, which is why it works. And now let's go ahead and take a look at a little bit different scenario here. You're going to notice that the variable isn't technically a part of this fraction here. The fraction's in front of the variable. So I want you to note the difference between the two here. So let's go ahead and first start by building that wall. And I don't see an operation going on between the 2/5 and c. So just like in number 1, we have to assume that they are being multiplied right now. Well, the only way that you can get rid of this is to divide both sides by 2/5. But if you learn this in class, which you should have, you're going to end up with 2/5 divided by 2/5, which is a division of fractions. And division of fractions is a little rule, and if you saw one of my previous videos, we talked about dividing by fractions. You actually want to utilize keep, change, flip. So what we're going to do is we're actually going to multiply both sides of the equation by the reciprocal. And all that means is you take 2/5 and flip it. So the 5 is going to be on the top, 2 is going to be on the bottom. And that's exactly what we're going to do for this. So we're going to multiply by 5 over 2. Again, I know it's crammed, get over it. And we're going to multiply by 5 over 2 over here as well. And again, I want to show you why this works, or else it doesn't really make sense. Well, oh, he's telling me to do inverse operations, but now I have to multiply by the reciprocal. And maybe this guy's a psychopath and doesn't know what he's talking about. This is the one thing I want students to remember the most, is if they see a fraction in front of the variable, instantly it's a go-to, hey, I got to multiply by the reciprocal, and kind of get in that mindset like, hey, this is the one that kind of is unique or stands out and is different. So take a look at the numbers that are diagonal from each other. So we have 2 and 2. Well, 2 and 2 are both divisible by 2. So 2 divided by 2 is 1 here. 2 divided by 2 is 1 here as well. Well, look at the other numbers. 5 and 5 are both divisible by 5. So 5 divided by 5 is 1. And 5 divided by 5 is 1. Well, what is 1 times anything? It's going to stay the exact same. And we do get c by itself isolated on the right side, which is exactly what we wanted at the beginning. And then we have 5/2 times negative 22. Now, some people, especially if they don't get a calculator, they might struggle with this a little bit. So this is 5 over 2 times, and this might make it easier if we just make negative 22 into an improper fraction just by putting it over 1. And now we can simplify things a little bit to try to narrow this down and make it a little bit easier. So can you divide 5 and 1 by anything that's going to simplify those at all? No. How about 2 and 22? Are those divisible by anything? Well, they're both divisible by 2. 2 divided by 2 is 1, and 22 divided by 2 is 11. And now we can go ahead and multiply our numerators together. So 5 times negative 11 is going to be negative 55. And, well, 1 times 1 is just 1. So our final answer is going to be c is equal to negative 55 for number 5. So this one is the most amount of work for one-step equations. All the other ones are typically a breeze, but when you see a fraction in front of the variable, instantly think multiplying by the reciprocal. And now we're on the very last one before I give you 6 problems to try out on your own in the practice session. So let's go ahead and build that wall once again. I don't see an operation going on between 16 and x, so they're being multiplied here. So the only option is to do some division and divide both sides by 16. Well, 16 divided by 16 is 1. 1 times anything, it's going to stay the same. So we isolated x just like we wanted to. And 32 divided by 16 is 2. And there we have it. Okay, that is the first 6, and now I want to see what you can do in the practice session when we're solving one-step equations. So it's time to actually lock in and go 6 for 6, and let me know in the comments if you did it or not. Let's get into it. Now it's time for the practice session. It's time to actually lock in. You know, if your mom or dad is downstairs right now yelling to you that dinner's ready, well, you're going to tell them that you're going to starve tonight, because this is the #1 priority. No food for you until you go 6 for 6. So if you go 5 for 6, I don't care. You're going to do them again until you go 6 for 6. You are starving until you get a perfect score. So without further ado, let's go ahead and get into this. Pause the video, try out all 6. When you think you're ready to go, come back and play the video and see how you do. So I'm assuming at this point you've tried out all 6, or maybe you clicked off the video because you're like, whoa, I am not starving. And I completely understand that, but I don't at the same time. That means you're not locked in, you're not focused. Let's go ahead and look at #1. So I'm going to build that wall separating the left and the right side. We're trying to isolate S this time and get it by itself. So the very first thing you should have done is divided both sides by -7. Well, -7 divided by -7 is 1. 1 times anything, it's going to stay the same. So we isolated S and got it by itself. And 49 divided by -7 is -7. So hopefully you're 1 for 1. You should have got S is equal to -7. Then for #2, build the wall once again. We're going to add 12 to both sides because we're subtracting, so we want to do the inverse. So these cancel, they're opposites, and we're left with X all isolated on the left side. -25 plus 12 is -13, and hopefully you are 2 for 2. For #3, very, very similar to #1. So we're going to build the wall, divide both sides by -11 because it's currently being multiplied. So let's go ahead and cancel these out, and we isolate M by itself on the right side this time. And then we get -121 divided by -11. That turns to a +11. And again, if it bugs you, just flip it. It's M equals 11. And for #4, I see X is a part of the fraction, so this is really just X divided by -8. So we're going to multiply both sides by -8. So again, let's build that wall, making sure that we multiply by -8 on both sides. I know I'm crammed for space here, so just bear with me. We know that these are going to cancel because this is essentially just over 1. So these would cancel because they're both divisible by -8. And then we're left with just 1s, which leaves X all by itself on the left side. And then 12 times -8 is going to give us -96 for #4. And now we're going into the home stretch, the last two. I do see a fraction from the variable right then and there. That should have clicked with you. Hey, this is a reciprocal question. So let's go ahead and multiply both sides by -8/3. So again, we'll build that wall separating the left and the right side. And we are multiplying by -8/3. Multiplying by -8/3. We know the 3's are both divisible by 3, so those turn to 1's. The 8's are divisible by 8, so those turn to 1's as well. And then we're left with C all by itself, isolated on the right side. And again, we might have to do a little bit of work here. So this is -8/3 times 18/1. And let's check to see, hey, can we simplify anything? Well, 3 and 18 are both divisible by 3. So 3 divided by 3 is 1. 18 divided by 3 is 6. And now we can go ahead and multiply our numerators and our denominators. So 8 times 6 is 48. And 1 times 1 on the bottom is just 1. We just want to make sure that our final answer, though, is -48. And if you got #5 right, you better not miss #6. Going into the final question, building the wall, separating the left and the right side, you should be subtracting 25 on both sides for this to get the variable isolated. These cancel. You get S by itself, and you get -13 minus 25 is -38. Did you go 6 for 6? And if you did, please leave a like on the video, comment any other topics you want to see, and subscribe. Turn on that bell for post notifications. We are in the home stretch for 100 subscribers, which is pretty big for a math channel, at least I think so anyways. And again, remember that I am giving out those blue calculators to 5 of you guys. Again, I know it's not crazy. Get over it. Okay, I'll sign it for you. I'll ship it to your house. I don't really care. But if you weren't here for that, I will show you what they look like, okay, just so you know I'm not bluffing, right? I'm not one of those people that are lying. Okay, we got the TI-30XIIS. It's good for middle school students, even high school students. I just thought it'd be something to show my appreciation for people that have subscribed thus far. You are the beginning of this math channel. You're helping this grow, you're helping this succeed, and I want everybody, across the world to be good at math and not be afraid of this topic. It's an enjoyable topic when you get good at it, and these videos are here to help you out. So we'll see you in the next one with some more mathematics. Again, thank you guys for taking the time to watch, and we'll see you in the next one.